Hello everyone, welcome back to another video of PLC tutorial series. In this tutorial we'll learn how we can do height based product sorting using PLC program and factory IO environment. In this video we'll be sorting product based on their heights. So at the very beginning, let us build the simulation environment in the factory IO. Then we'll understand what components we'll need, what are the inputs and outputs. After that we'll jump into programming that PLC. So let's get started. Well, very first we'll go to File and select the new scene for our setup. Here from the right hand corner, here we have palette window. Go to palette window, select it, and from here choose conveyor belt. Here we have 2 meter, 4 meter and 6 meter conveyor belt. Let's bring in one. This is called belt conveyor. Now suppose we want to sort product in a different line. For that we'll bring in a chute conveyor. Now suppose you have a control box for starting and stopping the operation of conveyor. For that reason we'll bring in a electrical switchboard. You can bring it up a little bit by pressing V. Now for starting operation we'll bring in a start button, and for stopping operation we'll bring in a stop button. So this is our start button and stop button. We'll also need indication for starting and stopping operation. So let's bring them. Press V and pull it up. Place it properly at your desired location. Now let's bring in the light indicator red. Okay, so now we have two switch and two indicator lamps for our setup. Now we will need a pusher to push the product into this chute conveyor. For that reason here we will go for pusher. You can also find that by searching in this search panel. You can just simply type push and it will bring in the push. So let's see this pusher here. We need to adjust it to the proper level. Let's align them with this chute conveyor in the middle. So these are the actuators and the conveyor belts necessary for this setup. We'll need sensors also. Here we have different types of sensor. This one is diffuse sensor. Let's bring it into the scene, and suppose we want to sort the large boxes only. So when we run this simulation we will find that only the large boxes will cross this diffuse sensor beam. Let's extend the beam a little further here. Okay, the setup is almost complete. Let's bring in some emitter and remover. So this green arrow, downwards arrow, this is a emitter. So from where you want to start the product, you place this emitter there. Let's bring it into the, select this emitter and properly align it with the conveyor belt. You can bring it down a little bit by pressing V. For vertical movement you need to press V into the factory IO setup. So now we will need remover into our setup. So let's bring it. One remover will place at the end of the belt. You can also see whether it's properly aligned or not. Press it and bring it down a little bit. Also we'll need another remover at this. Press V and bring it down at the end of the chute conveyor. Okay, so that's it. That's all for the setup. Now once we have developed the scene for our demonstration, we'll be saving this scene in the computer. Let's go to save as, give it a name. Let's say product sorting 1 and save it. Now let's analyze this scene for its input and output. So here in this slide we can see the whole setup and the input output device list. So here at the very first we have input device, so let me mark them. This is the first start switch. The start switch is here. We have stop switch is here. We have diffuse sensor, so diffuse sensor is connected with our pusher top that will sense the height of the box. Then we have pusher back limit and front limit. These two sensors are connected with this pusher device. So once this pusher arm extends to the highest limit, then the front limit it is turned on, and when again it rolls back and goes all the way down, then the pusher back limits turn on. So these two limit switch, this indicates whether the arm has extended all the way up or it has goes down all the way. So this is the way this is how we can understand whether our arm has been resetted or not. We have output device like this conveyor motor. This is connected with this belt. So this conveyor motor will be our conveyor control, that is we'll be using Q1 for that conveyor control. We have start light and stop light. These are indicating lamp. These are this indication lamp. We have pusher, that is our actuator, this pusher. So here we have indicated the input and output pin distribution. For start switch and stop switch we will use I1 and I2. For diffuse sensor we will use I3, and the pusher back limit and front limit, for that we will be using I4 and I5. So we have total 5 inputs. For output, the conveyor motor will be connected to Q1, the start light and stop light will be connected to Q2 and Q3, and finally the pusher, it will be connected to Q4. So we have 4 output for this scene in our program. So according to this pin distribution of inputs and outputs, we'll be designing our PLC ladder diagram for this setup. Well, before going into the ladder diagram development, we need to configure our factory I/O setup first as per this pin description of input and output. So we have 5 input pins. Let's connect them first. Start switch, stop switch to I1, I2, diffuse sensor to I3, and back limit I4, front limit I5. So we'll go to factory I/O setup. From here we'll go to file and choose the drivers. Here you will be having a list of PLC devices. You can choose anyone from here that you have at your hand. I have Siemens logo, so I am choosing this one. Now as per my diagram, I will be connecting start switch to the first input, then stop switch to the second input, diffuse sensor to the third input, back limit to the fourth input, and front limit to the fifth input. So these 5 inputs I have connected here as per my connection description. Now I have 4 output to be connected at the factory I/O setup: conveyor, start, stop, and pusher accordingly. So let's bring in belt conveyor first. This is my first output. Then start light, that is the green indicator lamp. Then stop, these are buttons. Green, yes, this one. Green light indicator, then red light indicator, and then finally the pusher. So these 4 are my output devices for this setup. So now we can go into the Logosoft Comfort software for Siemens logo and develop our PLC program for this demonstration. Let's do that. Now let's do the programming for this demonstration. I have opened the Logosoft Comfort software. From here you need to take a blank ladder canvas. So here the blocks will be on this left side of this canvas. Here you will get the instruction, and from here you have the contacts. Under this constant tab you have latching relays in the miscellaneous tab. So for this program we'll be using basically contacts and latching relay. So this latching relay, let me demonstrate it first how this works. So this is a relay that has two input, that is first one is set and the second one is reset. So let's suppose we have our start switch, that is our make contact. Let's connect it to I1, and we have our stop switch, that is I2. Now once I press this I1, I want to set the output of this relay. For that reason I will connect this I1 to set, that is this S terminal. S stands for set. Then I2 is my stop switch, and I want whenever I press this I2 switch it will reset or turn off the output of this relay. So for that reason I will be connecting this I2 to this R pin, that stands for reset. Now the output of this relay, to demonstrate that, we will be bringing another make contact. This make contact would be our latching relay. So bring it down. From here you will find latching relay. Press OK. Now bring in a coil, that is Q1. Well, let's say we want to operate a flag for now, that is M1. Okay, so this is two input switch and one output with latching relay, and let's see how this latching relay actually works. So let's do another thing. You can also make them momentary push button. This I2, block properties and choose momentary push button, and let's do the simulation again. Here once I press this I1 and release it, this M1, that is the memory flag of this latching relay, it will kept turned on, and whenever I press this I2 it will reset it, that will turn it off. Again set, reset. So that's how a latching relay works. Well, as we have now the concept of latching relay, let's build the program for our real demonstration. We'll first bring in the latching relay in the scene. So this latching relay, this would be our first latching relay, and we'll be using two switch. The first one is I1, that is our start switch, and the second one will be I2, that is our stop switch. Now remember that we are using, when we are working on virtual environment, that is this switch, these are not physical switch that is connected to PLC. These are virtual switch in this factory IO scenario. So that means these are inputs from network that will be given to our PLC hardware device. So these are our network inputs, this start switch, stop switch, these sensors and these limit switches, these all are our network switch. So for that reason, when we are adding switches or inputs in the canvas, we'll be actually adding network input. So let's bring first network input from here. So we have total 5 network inputs. Let's bring them first. So click network. So here we have brought total 5 network inputs. Let's configure them. This first one is V00, the second one would be V01, the third one would be V02, V03 and V04. All these will have variable memories and up to 0.0 to 0.4. Now this first start switch we are working on, this would be our network switch. The second switch, that is the stop switch, will connect this to NI2. So now you might ask why I am choosing break contact for stop switch, because if we see carefully in this scenario, here I have stop switch, this one, and if you go to file, drivers, and look carefully, if you notice here, this stop button, this is already NC, that is normally connected. When I press it, it will be normally open. So this has already power, so that's why I don't want to trigger the output when the stop switch is not pressed. That's why I need to connect it as NC. Okay, so when I power up the PLC, it is normally closed, but due to this nature of this stop button here, it will open up. Okay, but when I will press that stop switch, it will again close the contact. So that's why this is breaking contact I am taking for this. It will be more clear if I connect them. Let's bring in make contact for this RS001 latching relay, and I will be taking a memory flag for this, let's say M1. I will upload the program part by part. So at very first I will check if our start and stop switch work properly. So now to turn on the conveyor belt using this start and stop switch, we'll bring in second latching relay, and this latching relay is for conveyor belt. Now this conveyor belt, this should turn on only when this memory flag, that is M1, this is on. So let's bring in the M1 contact and connect it to set, and it should stop, the conveyor belt should stop only when I press the break contact, that is I2, sorry, not I2, NI2, network to input. So now I have set the second latching relay. Now let's connect the output of this second latching relay to our conveyor belt, and our conveyor belt is relay coil, that is Q1. So if I upload this program to my Logo PLC and connect it to factory IO, this simple program should be able to run our factory IO conveyor belt using the start switch and stop switch. Let's see that if it works. Now to upload this program, first we'll go to network project, and from here we'll add new device, and here you need to put the network addresses for your PLC. Here I am putting the addresses associated with my PLC. So again, come back to diagram mode, go to tools, transfer PC to logo. So sorry, because here we have unconnected two network output. Let's delete them first. We do not have used them yet, that's why the error is coming. So now let's go to transfer PC to logo, choose the IP address of your PLC, then press OK. Now go to factory IO software, go to configuration, put the address of your PLC logo, that is IP address here, go back and press connect. Okay, it's now showing that the PLC is connected to the factory IO setup. Now you need to press this simulation button, and now if I press OK, see the conveyor belt is running, and if I press stop, the conveyor belt is stopping. That means my start and stop button is working fine. Now we need to do more programs for this setup, because whenever this large box comes in front of this pusher, we want to stop this actually this conveyor belt and push it down. So for that reason we need to update our PLC program. So let's do that. Now we need to stop the conveyor belt whenever the sensor senses the large box. To do so, we need to bring in another network input. So let's bring in another network input here, and this network input is our V0.2, and this network NI3, it stands for the diffusion sensor. So we want that whenever this diffusion sensor senses a large box, it should stop the conveyor belt. And this diffusion sensor is normally open. Whenever it connects, it will normally close. So you can also check that from this driver option. You see this diffusion sensor is normally it's not powered, but whenever it senses, it will power it up. So for that reason we need to bring in, so let's make some space here. Okay, now if I upload this program to PC to logo, choose this IP address and press OK. Now come back to factory IO, press this connect, or you can do one thing, go to configuration, click this auto connect. It will automatically connect whenever the PLC is available. So now if I run this simulation and press a start button, whenever a large box comes before this diffusion sensor, it will automatically stop the conveyor belt. So these are small boxes and this one is large. Whenever this large box comes before this diffusion sensor, it stops the conveyor belt. Now what do we want? We want it to push down. So for that reason we'll need to actuate this actuator. Okay, so let's do that. Now for actuating the pusher, we need to bring in another latching relay. But remember, this latching relay, we want it to activate only when the I3 senses a box. So let's bring in NI3 here. So whenever NI3 senses, and also whenever the NI4, that is the back limit, is not reached. So NI4, sorry, I need to bring in the network input first. Network input, and let's give the memory. The earlier one was V02, so we can also bring them up. V0.3, we need another network input, V0.4. So this 0.3, that is NI4, is it is for back limit, and NI5 it's for front limit. Okay, so this back limit should be our in starting setting condition or a starting condition. Whenever this pusher reaches its maximum limit upward, it should turn this front limit on, and only then it will start resetting the actuator. So for that reason, this NI4 should be our resetting pin of the pusher. Let's connect them together and bring in another make contact for this, latching relay. Sorry, this is not NI4, this is NI5, and bring in a relay coil, and this relay coil is nothing but the pusher. Also we have two other outputs, that is this green line and the red light. So this green light would be turned on, that is Q2 will turn on whenever the conveyor belt is on. So let's connect it here, and Q2 it will, so let's bring in Q2. It will connect only when the conveyor belt is not running, that is Q1 is not running. Whenever the Q1 is not running, the red light should turn on. So that's it. This is the program. Disconnect this. Before uploading, let's review it. I have NI1, NI2, NI3, NI4 and NI5, 5 network input. I have 4 output, Q1, Q2, Q3 and finally the Q4. As we have a space, we can bring this down to here. So what we have done, the first latching relay, it stands for the memory flag M1. The second latching relay, it will be used for the conveyor belt turning on and off. For turning on, M1 memory is responsible, and to turn it off, the stop switch and the diffusion sensor is responsible. Now the third latching relay we have used for actuator, actuating the pusher. The pusher will turn on only when the NI3, that is the diffusion sensor, senses and the back limit is reached. Only then the actuator should work, that is the pusher should work. Once it works actuating, we want to reset it only when the NI5, that is the front limit, is reached. Then after resetting it, the whole cycle repeats itself. So that's the whole program. Let's upload this program to our PLC. Choose it and press OK. Go to factory IO. From here, press the simulation, the start button. There's a larger box is coming for the diffusion sensor. It's pushing it down. This is a small box. It hasn't actuated the diffusion sensor and it keeps passing. This is another small box. So once the larger one comes, it will actuate and pass it down. So I hope you can now program a pusher and a sorting program based on heights. So if you want to avoid those pallets and crashing it into the conveyor, you can do so by going into the emitter, right click on it, go to part to emit. From here, palletizing, choose the palletizing, untick this, and also base to emit, untick these pallets. So if you want to emit the larger and medium box, choose these tools, and now the boxes will be only on the conveyor belt, not the pallets. So this is how you can program a sorting program on PLC and factory IO using height-based logic for sorting. Hope you understand this whole program. If you like this program, please like this video and subscribe to my channel to get further videos like this. So see you in another video.